Okay, and we are back. It has finished installing. So what is the next step? Okay, let's follow. What is the next step? Okay, sudo app. Okay, let's resolve the Python first. Let's say remove Python, root sudo app, remove Python. Oh crap, what does this say? If we remove Python, then the following package will be removed. See, so it's very dangerous. So probably we say no, but probably we want to install Python 3 is Python. Unable to locate. Python 3 is Python. Python is Python 3. Python is Python 3. Yeah. Unable to locate the package. Python. Okay. So maybe we have to do this. Alias Python equals Python 3, right? So exit this because we are so here we are in the environment, Python environment, the freedom interpreter. Okay, exit. So what is it saying here? Like the bash RT. So uh, as so when we have the VS code, we can say code, and in order to inspect any file, you can just write that file down. Then it will show up, pop up. Yes, I trust you. I open, I trust. So the bash RC file usually will be in outside here, the home at home at the home directory. So the bash RC file, what does it do? It runs at the start of our session. So for example, I said echo hello, start of the session, right? And then I saved it. So now when I open a new one, yeah, it says start of a session, start of a session, start of a session. And what is this interesting terminal that I just open here? It is called Terminator. Why do I use this? Because it allows us to open a lot of sessions, and that is a very common theme in doing with ROS. We need a lot of sessions to run various things in parallel, not parallel, but in different sessions, so that it will not block the rest. So what do we do next? Another sudo app install. That's why it's yes. So basically, just install everything. It doesn't need to stop and ask me for the yes thing, right? And then there's this thing called environment setup. So what does it do? So you see that here in this line, they said that echo source of broad map thingy. So what does it mean? This line source means that it will be. So let's think of it this way. Just now we just install ROS melodic, and it will create for us this directory with this file called setup bash. So in the setup bash, it will start defining various software or various command that is available to the command line. And we have to source it because if we don't source, the command line will not know the existence of those commands. For example, there's one example, is let's say cross call. Cross call is very important for the ROS operation, for ROS one running for the whole system to run. But as you can see, it is not there. Why? Because we have not tell the operating system where the command is. So melodic setup bash. So we have to write it in the bash RT file. So what does it do is echo is what I just write. So echo is just repeating and put it double dash is like put it into this file called bash rc. The tilde is home. So source bash rc, basically we are telling that. So every new session. So let's just put it. Yeah, new session. Let's just put it here for uh, you know, annotation purposes. So when we say every time we open a new session, right, then is a new session. So now if we try ROS call, yes, now it is running correctly. Earlier, without the sourcing, the ROS call will not run. So we want to clear this, clear, and I think thing is done. Okay. Install package. Okay. Install Python ROS dev, right? Sudo ROS dev. Okay, ROS dep update. So basically, ROS dep again. ROS dep is ROS dependency, and when we do init and update, it was similar to sudo apt update. Basically, it will reach out to the cloud to the online repository and see if there are any changes, any update to the existing software there, and it will update accordingly. Okay, so now is the juicy part. Is the installation. So let's go and follow what they uh, yeah what they suggest. All right, go to the GitHub. Yeah, requirement, ROS, kinetic, etc. etc. Sudo app environment. Okay, so here virtual environment because you want to segment the various development environment. But I think we don't need that. We can just install everything out here. I allow you to do that. So first we need pip install. So Python first, Python. See if it's correct. Okay, so Python. Okay, wait, sorry. Alias. Right. So in this, we have to do alias. Python equals alias Python equals Python 3. To tell Python 3. Yeah. So now we close this, we open a new one, Python. Now Python is Python 3. It might not affect much because we can explicitly say Python 3, just to be safe. Similarly, pip is another package management for Python. Pip 3 is for Python 3. Python install, I want to type, just pip 3 not found, okay? So apparently pip is not installed with Python. Okay, can install them. Install it. Yes, I want to install. So install that, create a workspace. So this is, I will share with you, this is a main structure of a ROS workspace. What does it do? While it was installing, we will make dir, make directory, key is create the parents. So I want to be at home, I want to go Jekyll workspace following this, right? Just follow it. Don't need to be so, uh, you know, don't need to be so particular. Let's just follow. And you can see after ls is list out like Jekyll workspace. So now when we do code dot, no, I think we should go to the Jekyll first. Jekyll workspace. Code dot refers to the current directory. So when we do that, VS Code will open the current directory, and in our file we have a Jekyll workspace with the source. So what do we do next? So here is just a visualization. That Jekyll workspace is the top of the food chain, right? The top directory. So let's continue. CD change directory, CD change directory, which is what we did. And then we need to go to the source. We need to go to the source because so the source similar to the concept we shared about C++. We need to put our source code in the source folder, and later on we build folder. So here we need I don't think we have Git. So now we need Git because Git is a version control and it will allow us to interact with the uh, interact with the GitHub repository. So now you can see that we need to install all these. Let's go. ROS version. So we need to substitute this melodic password. Enter a password to unlock your Kotlin keyring. I don't know what happened there. Again. Melodic. Devel. Melodic. Devel. Eban. Git. Yep. So why do we need to be particular about melodic? Because some of the branch doesn't exist in other files. So It's a problem. So now you can see that git clone the bound challenge, but we don't do that. Let's go to MLDA. See if we can MLDA bound GitHub. I don't think we are. Yeah, we are not. Well known enough to be the top search result. But you can go to MLDA repository and get the NAT notation. So get the correct link and also git clone there. Git clone our link. Yep, that is correct. And then after all of that, we go back out. Right, we go back out. Yeah, then they say that source the ROS again. But because we just source the ROS, we don't need to do that. We just need to ROS dep install. Okay, this is where the magic happens. Okay, this is where the magic happens. So ROS install, that's why it's yes, say yes to everything. Ignore source. Sometimes I was also not quite sure what these mean as well. But from path means from the current workspace. From dot is current directory, and current directory is the exact workspace. Source dot distro equals melodic. So what it does? What does it do? Cat key. I thought we have cat key. Wait, did we source? Ross call. No Ross. Oh, this is the old. Okay, my bad. That was the old session. Yeah. So the idea of a session is also quite important. You can see. We need to close this old session because the new session should have Catkin. Catkin có bé lắm. Crossbar is found, but Catkin is not found. Why is Catkin not found? That is very strange. Okay, never mind. Let's see cd capital this. Okay, paste this. Font version. Melodic. Okay, so Catkin, as you can see up there, Catkin is found, but the following step cannot define Java state. You are based not for Hector, relevant description, and all of these things. You cannot get them. So when we have them, it's very important. But the what happens? So ultimately, what we need to do is in the in the many of the packages are based on C++. So you can see that it will start trying to build all of these packages and it will hit a problem. Okay. It says that, okay, where is this base local planner? Huh? I need this base local planner and you're not giving me that. So how? What is the solution here? I need to find all of these packages. Then the solution is we need to go to the cd Jekyll workspace list cd source. Right, Jekyll simulator. So these are our existing packages, the source packages. But like I said, it depends. They depend on other packages. And just now the ROS dep has shared with us what are the packages that need them. So join state, publish, move base, navcore, hector, velodyne, twistmux. So usually they will be under ROS navigation. Yeah. So navigation. So in here, what we can do is they also provide us with a .git file. So technically we can, so you can see move base. We need a move base. here is the move base, right? There's a nav call. We need a nav call. Yeah. So basically, we need to put all of these components in the correct place in order to build the whole project completely. But then we can either git clone this as well. But another thing that we can do is sudo apt install ROS melodic. Right, you can see if I do double tap, then you can see that there are 3,000 possibility. It means that there are 3,000 kind of package that is built for ROS melodic, and usually I think it should be ROS navigation. Let's try. Yep, it will start installing. So this is the process of discover what package what packages are missing in order to install them properly and correctly. So using ROS, uh, so the thing that we need to install using pip, and then sudo apt, and then we can use ROS there to see what is left over. Okay, the value description, G mapping, G mapping, right? G mapping here. G, G mapping, yeah, there's G mapping. Install, right? So before we can pull Git, description, this, in what addition to this context, publish yeah, victim. Okay, there's no victim. So for that, I think we need to. Oh, Melo, Dick, victim. Ah, now there's a big victim. Okay, that is my bad, my typo. I don't know what victim is. Yeah. So you can see that I also don't know a lot of things, because the point is that all of these dependencies usually comes with experience and comes with knowing what the community, what the wider research or industry community has built in order to utilize them. So when people said, I know ROS, you don't expect them to know all of the packages, because we only know the thing that is necessary for our use case, right? Now we only have three left. Out, and they're all this. So what I did was just now was a tap. So when you are halfway finished, command, when you press that, the system will have to auto complete if it can, by checking against the database. If it is able to auto complete, I think it will be and people. Oh, So in the future, if we don't do all of these camera description. Ah, shit. I'm sorry, language. I should have used the. It can install everything at once, so we don't have to do what I had done. Oh no. This server. What is left? LSM. LSM. That sounds very strange, but no problem because it is also developed for ROS melodic. And after all of these, it will come out all required ROS depth installed successfully. Good job. So when we do Catkin build again, oh no, Catkin make. Can make, okay, generate. So you can see build target. So it just built, finished building, right? It just finished building. And you can see over here, what are the paths? We have we have the various paths for various things. So base path is where our Jekyll WS, our workspace, WS stands for workspace. And there's a build and develop. So build and development, we don't touch. Those are an artifact, an outcome of the catkin command that we just run. So catkin make is a process to trigger the build sequence, right? So the build and development folders will be generated, but we're not interested in them. So what are we interested in then? So we are only interested in, yeah, we're only interested in the source. And over here are the various packages that we can directly influence. So let's go to source, list. And because can only directly influence the source, it's probably better to make our source, straight from here. So let's check if our run, right? If this runs correctly, let's check against the nav competition. Right, nav competition. After that, clone this repo. Oh wait, no, here. Yeah, cat can make. Okay, so after cat can make, we're done. It's effectively done. Run simulation. What we can do is run python 3.run.py world ID 0, right? Which is here. But we want a full path, so copy path. And let's make a test file. Not test file, but then command file. Command markdown. So that we can put the code that we want, run.py, right? So we want to run this using Python 3, and we want to tell it world IDX is 0, and also GUI. The GUI will pop the GUI up, and in the VS Code we also have access to the terminal. Okay. So we workspace. The workspace also is solved. Right? So we solve them. We also which is workspace level. but it's very laggy. Oh, no, that is not good. I think to combat this lagginess, we need to provision more CPU resources for the virtual machine, or we have to like install everything all together directly on the computer. Huh. It's all right. It's all right. We can do that now that you know how to do it. Yes. So this is how things get done. And when we talk about ROS, right, ROS tool, visualization tool, what do we have? What can we have? So there's this thing called ROS, opacity graph, which should pop up graphical command, yeah, graphical interface. What does this graphical interface see? So you can see that these are the ROS nodes. One ROS node is in charge of a certain component of, you know, commanding a robot. So using this visualization, we know which node is communicating with who. Right. So we have, for example, move base. So what does move base do? So move base will receive a move base goal, and from that it will negotiate and communicate nodes such as EKF documentation and where is the robot to communicate with all of these to output a twist. A twist is a vector where to go. X1 and theta. So twist, and then from the twist, the velocity control, velocity control, which is yeah. So we need to do now is to propose algorithm and create helper files to run these experiments multiple times in multiple different worlds. Right? So if we want to run it in a different world, we just need to give it a different index number. So different worlds will have different difficulties. Gazebo simulation makes it easy. Right. So now the task is very difficult, much more difficult than earlier. Yep. So that is all.